Okay, I'm explaining some of the assignments from the yesterday, the Monday, September 9th, for the lesson of 4.3, okay? This question from the assignment of 4.3, AP Calculus. And look at here. Basically, this lesson is a talk about something relationship between the continuity and differentiation. And also talk about from original function. For example, you have an original function like this one, right? For example, this original function fx, for example, like this. So, and the derivative of this function will be basically the derivative of the function will be what? Like a 1 here. That's f derivative of function equals 1. Because the slope of this line, original function, is 45 degrees. Slope is a 1 there. This angle is 45 degrees. So that's why derivative is just equals 1. So relationship original function and the function, no, original function and derivative function. Derivative function is the slope of the original function graph, okay? That's the basic things. So we're gonna go over each of the questions, some of them here, so you can like see how to apply those things. Continuity, differentiate, derivatives, and the original function of the graph and the derivative function of the graph, okay? Now below is the graph of the function fx, right? Y equals fx, this one, huh? This is from your observations of this graph state with reasons, the value of the values of x at which f is not differentiable, okay? Definitely here we know at here x equals 6. That's not differentiable because this one is not continuous. If it's not continuous, definitely not differentiable, okay? Because there's a gap there, okay? And also we can find what here, that's the point here. This is one of them, huh? Here is not differentiable. Here, this is a sharp corner at the 4 here. So x equals 4, that's the time also not differentiable because we call this the sharp corner. Why sharp corner is not differentiable? You think about this way here. The reason is this. On this side, this one is, the slope is going this way. And on this side, the slope is going this way. They have different slope at that same point. Means left slope, when the x approach to the 4 from left side, and then when the x approach to 4 to the right side, they have different slope there. So that's why derivative at x equals 4 is not exist, okay? So that's another point. And then we can tell the sharp corner is here also. So that means what? X equals 2, that's here. Also not differentiable. And for the other part here, all this is a smooth curve. For the smooth curve, okay. All right? So I think you understand this now. Huh? Not differential, not continuous, definitely no derivatives. Even though at here, there is no gap. This is continuous at here. But since this is what the sharp corner, the left derivative and the right derivative not the same. That's not differentiable at this point. And also here x equals 2, okay? So let's move on. We go to next question now here, right? Okay, let's move on, okay? We go to here, this one. The second one, they said, consider the function fx equals this, x plus square root absolute value of x. Use the graphical methods to discuss the differentiability of the function. In particular, find all the values of x for which the function appears non-differentiable and explain why. Include at least one graph illustrate what each point on non-differentiability. Okay, let's do this one here. Let me erase this one first. Let me erase this part. Now, when you go to here, when you look at this question here, they ask you what? You need a graph of this one first, okay? So graph, you may graph it by hand, but here we can have a better way. We can use what? Desmos graph, okay? Let me show you how. You follow me here. We go to next. Oh, wait, hold on. Make sure it's right. Okay, it is recording, huh? Okay, it is recording, okay. So we need to graph it. And of course, you can use the graphing calculator. TI 84 is fine. 86 is fine. 84 is fine. But you can use what? Another part. We call this decimal. Okay, let's go to here. Decimals. And we can go to the function here first. Okay, we go y, right? Y equals to, let me just show you how to use it, okay? Equals x and plus, right? And plus square root. So we need a function now. Square root. Square root. What's that? Square root. Okay. So we have square root of what? Absolute value, right? We're going to find the function of the absolute value. Where's the absolute value? Oh, where's the absolute value here? Hold on. Let's find the function first. Okay, look at it here. So we have y equals to, in the x, and here they put as what? You can put as 2, okay? And the square root. But generally, square root, you don't need to put 2 there. So we can recognize that, okay? But here, they said absolute value of x. So you can put what? This is the key for the absolute value here. And then you put in the x, okay? So if you do, if you do that, and then you will get what? This is absolute value. Closing this one. Oh no, hold on. So make sure we got this one here. Absolute value. Okay, I got this one now. Huh? And you can put the 2 here is fine. You can put 2 here. So you see here, this is the graph we got after we put it in, right? Let me show you more graph here. So when you see this graph, you can tell here, you can clearly see at this point here. Here is differentiable, no problem. Smooth curve, differentiable, no holes, continuous, and also no sharp point, sharp corner. But here, this is the one. This is the one, make what? X equals 0 at that time. This function is not differentiable. Okay? So let's go back to this question we have. Let's go back to the question we have. Where we had now here, we're here. Okay, hold on. So we go to here. Where's the lesson? Oh, hold on. Okay, you can see that from that graph, we can tell, from this graph here, you can tell when x equals 0, that's the time the function is not differentiable, okay? So let's go back to here. When you go back to here, you can see Implicitly find the value of x for which the function appears not differentiable. Explain why, because that's sharp point, sharp corner. Sharp corner and left unit and right unit, right derivatives not the same, okay? So now let's move on to next one now, okay? Let's erase this part here. When you look at this one here, you can see number 3 now, okay? Consider the function of this. Use the graphing methods to discuss differentiability of the function. In particularly, find the values of x for which the function appears not differentiable. Explain why. Include at least one graph illustrate each value, each point of the non-differentiability, okay? For this one, similar like what we did here. We need like what? Get this function first. Hopefully I can copy and paste this one there. Or I just write it down. Hold on. I'm going to, okay, now we're gonna graph this one, okay? The same method as what we learned from doing this one. I still use the decimals. I copied the question here, fx equals 1 minus absolute value x fourth power minus 5x squared plus 4, right? I'm going to put this one in the decimal, okay? And let's do it now. So we go by here, y equals to, right? And the 1 minus absolute value here, right? You can see how do I use this decimals, it's very useful, huh? And then we go x to the power of 4 here. And the minus 5, the x and the squared, eh? And then plus the 4 here. And then the closing absolute value here, okay? By keying all this function. You can see that here, when you look at the graph we got, you can see here, oops, hold on. You can see there are so many corner points there at here, the corner. This is no problem, this is differentiable. This one is not, the corner one. So we can see that x equals to -2. So we can see here, at least we can see x equals what? -2, x equals what? -1, okay? And x equals what? So 1, 2, 3, 4. Okay, this is 1 there. So all those, and also x equals 2 there. The function is not derivative. All right. So let's go back here. So that's what I showed you some of the question on the homework. And if you've got more time, I'll explain more to you. Okay. I will continue to this one if I have more time to explain to you about this. Of course, if you have any questions, please let me know. And I can explain more specific to what you have question on. All right? Thank you. Okay, bye-bye.